Today we have Professor Khoman Phang, one of the instructors for Fundamentals of Electric Circuits, also known as ECE 159.
I've been at the University of Toronto for about 18 years now. Actually, I did my undergraduate degrees here, so all 3 degrees here. So I've been at U of T for a long time as a student and now as a faculty member. I've been around circuits for quite a while. I started in Sony in Tokyo, Japan, and working on their early cell phones, and spent a few years at IBM Microelectronics, and came back to U of T to do my PhD in analog integrated circuits, and took up a position here and have been here ever since.
Tell us why you are passionate about teaching.
I love teaching. At U of T we have such great students, so there's a real dynamic in the classroom, students asking questions and being engaged, especially engineering science. I can always rely on students to ask how concepts that they learn in this course apply to other courses, and it's really exciting to engage students in what I think is one of the cornerstones of modern technology, which is circuits.
What is your favorite thing about your course?
I love how circuits is a precursor of what you can expect to learn in engineering, and what you can expect to do as an engineer. So in the course you learn about the devices, you learn about the basic laws of circuits, and then you quickly see how the concepts that you've learned in your mathematics courses and physics courses apply to circuits. And it's really exciting to see students quickly realizing that they can apply what they've learned in this course to actually building some prototypes, primarily in your praxis course.
What concepts in your course do people tend to struggle with?
I think the getting over the idea that you're looking for just the right answer. Circuits, certainly you need to apply your mathematics and do your algebra correctly to get the right answer, but that's really just the starting point. And a student that just thinks about the right answer as the end goal is missing out on what's really what I feel is the significant part of circuit design, which is really developing that intuition of what's going on in the circuit. So, the voltage might be 2 volts, but that doesn't tell us much. Far more interesting is, why is it 2 volts? Should it be 2 volts? Should we make it higher or lower? What should we change in the circuit to make it so? That is what we do as circuit designers, and in this course we start you along that path of going from just pure analysis to actually thinking about what the circuit does in order to work towards designing as opposed to pure analysis.
What available support do you have for students in your course?
This is a first-year course, so I find it very important as an instructor to give you resources. We're very fortunate in having online resources. The online homework system that we have, Connect, from McGraw-Hill, allows you to do your homework online. The questions are from the textbook, but it's algorithmic, so it will change certain parameters of the circuit so that each student gets a slightly different circuit, but the analysis process is the same. This allows you to check your understanding, and you submit the answer and you get immediate feedback whether your answer is correct or not. You get multiple attempts, so you can go back, and what I often find is that students will go on the discussion board or go into tutorials or my office hour to ask questions. Why am I not getting this right, sir? And that leads into a good discussion about how you approach solving the circuit. Are there more efficient ways of solving it? And it's really exciting when in an office hour there are a number of students there, then there's actual discussion and an ability to learn from each other how to analyze circuits.
What is your favorite memory from teaching this course?
I think they're the times when students are working on their practice project. That's really exciting because that's when I start hearing from students that they're actually applying the material, they're building some circuits for their project, and they actually learn. It reinforces their learning as well. I remember one student coming back to me and telling me that they had created a prototype that was outputting square waves and triangular waves into a speaker, and they noticed that the square wave was louder, noticeably louder than the triangular wave, and it clicked that what they had learned about RMS, or root mean square values of waveforms, was directly responsible for what they were hearing, which is this difference in sound, because square waves and triangular waves, they realized, had different amounts of energy, or RMS values.
Any closing remarks or anything else you want to say to incoming first years you may meet in the second semester?
Well, I usually start off by congratulating them for getting through the first semester. That's a real milestone, and I encourage them, now that they've settled in a little bit into the school year, into U of T, into the engineering science program, to really make the most of their experience. So grab the bull by the horns, be engaged, take part, and make the most of your school years, because there's just so much out there that U of T has to offer, and it's really just up to you to take advantage of that. So come out to my office hours, talk to your TAs, your professors. They all have interesting stories to share with you, and thoughts about technology and where it's heading these days, and learn from them. You'll learn a lot and you'll have fun if you engage with others.